Hello friends, today we are going to study about the revolution in measurement tools. We are going to discuss about the various measurement tools related to length, mass and time. The earliest known uniform system of weights and measure seem all to have been created at some time in the 4th and 3rd millennia BC among the ancient people of Egypt, Mesopotamia and Indus Valley and in Iran. In those times, length were measured with the help of body parts. Some of the examples are handspan, foot, yard, pace, cubit and arm length. Let's discuss these one by one. First is handspan. Handspan is the distance between the tip of thumb and to the tip of little finger. Foot. The distance between the tip of thumb of feet and its heel. Yard. 3 times the foot is called yard. Pace, the distance between the heels of 2 legs. Next is cubit, the distance between the tip of central finger to the bottom of elbow. And the last is arm length. This is the distance between your wrist and your shoulder. In ancient time, measurement of length was done with the help of bow, means dhanush. In Hindi we call it dhanush. Then, in the present time, we have measuring tape, ruler, meter scale, vernier caliper, screw gauge. Each of these used by different people for different things, such as measuring tape is used by tailors and architects. Ruler is used by students and architects. Meter scale is used by clothes merchant. Screw gauge or micrometer mainly is used by mechanical engineers for accurate measurements of components in mechanical engineering and machining. Similarly, we have vernier caliper. Vernier caliper is used to precisely measure the diameter of round objects like cylinders. Then we have measurement of mass. The grain, a weighing scale or balance, is a device used to measure weight or mass. Traditional form of balance consists of a pivoted horizontal lever with arms of equal length, the beam, and a weighing pan suspended from each arm. The unknown mass is placed in one pan and standard masses are added to other pan until the beam is as close to equilibrium as possible. It is both handheld and self-stand. Technically, a balance compares weight rather than mass, but in a given gravitational field such as Earth's gravity, the weight of an object is proportional to its mass, so the standard masses used with balances are usually labeled in units of mass, example gram or kilogram. The other balance used in ancient time was made of iron and wood, where on one plate there is known mass and on the other plate there is unknown mass kept. Next is the evidence of beam balance used in 15th century. This is the picture when Mughal Emperor Jahangir weighed his son in gold as a part of the celebration of his 15th birthday. Next is Roberval balance. It was invented in 1669 by Frenchman Gilles Personne de Roberval. The advantage of this was that no matter where equal weights are placed in the pans, the scale will still balance. Now, the measurement of mass in present time. A mechanical scale or balance is used to describe a weighing device that is used to measure the mass, force exertion, tension, and resistance of an object without the need of a power supply. Some of the examples are pan balance or beam balance, spring scales, hanging scales, triple beam balance and force gauge. We will discuss force gauge in another video. First is pan or beam balance. The invention of equal arm balance dates back at least at the time of ancient Egyptians. This is also called direct weighing. In the earliest type, the beam was supported at the center and the pans were hung from the end by cords. A later improvement in design was the use of pin through the center of beam for the central bearing, introduced by the Romans about the time of Christ. The invention of knife edges in the 8th century led to the development of modern mechanical balance. Now, next is mechanical balance. Mechanical balance consists essentially of a rigid beam that oscillates on a horizontal central knife edges as a fulcrum and has the two end knife edges parallel and equidistant from the center. The loads to be weighed are supported on pans hung from bearings. For best design, two or more additional knife edges are located between the end bearings and the pans, one to prevent tilting of the plane and another to fix the center of chord at a particular point on the edge and edge knife. Next is spring balance or spring scale. The spring balance or spring scale, also called Newton meter, is a type of weighing scale which consists of spring fixed at one end of a hook to attach an object to at the other. It works on Hooke's law, which states that force needed to extend a spring is proportional to the distance that spring is extended from its rest position. Spring scale is different from beam balance. On spring scale, as spring scale cannot measure mass but only weight. Next is hydraulic scale. It is common in high capacity applications such as crane scales to use hydraulic force to sense mass. It is a scale designed mainly for application in agricultural activities. Next is lever balance. This balance has been designed to plug the long felt need for an inexpensive, portable and robust single pan balance of modest size, capable of giving consistent and prompt reading to a fair degree of accuracy. Digital scale. Electronic digital scale display weight as a number, usually on liquid crystal display (LCD). They are versatile because they may perform calculation on the measurement and transmit it to other digital devices. So we have digital spring balance, which measures weight of an object in numbers displayed on screen. Then we have body weighing machine, both analog and digital. Next is digital kitchen scale, used for weighing food in the kitchen during cooking. These are usually lightweight and compact. Next is laboratory mass comparator. A mass comparator or comparator balance is a balance with best possible resolution and repeatability, allowing determining even the smallest difference in mass. These mass comparators are designed to use in national standard laboratory and in calibration, verification and legal metrology laboratories. Next we have is digital jewelry weighing machine, used to measure precious metals like gold, silver, diamond. Next is digital industrial weighing machine, used for industrial purposes. The other one is microbalance. A microbalance, ultra microbalance or nanobalance are instruments capable of making precise measurements of mass of objects of relatively small mass of the order of million parts of a gram and above. Next is triple beam balance. It is an instrument used to measure mass very precisely. The name refers to three beams including the middle beam, which is the largest size, front beam with medium size and far beam of smallest size. It can be used to measure mass directly from the objects. Find mass by difference for liquid and measure out substance. Then we have measurement of time. Measurement of time in ancient times. One of the earliest of all devices to tell time was the sundial. A sundial is a device that tells us the time of a day when there is sunlight by the apparent position of the sun in the sky. It consists of flat plate, the disc and a gnomon which casts a shadow onto the dial. Next is water clock. Water clock is used to measure time by regulating flow of liquid into or out from a vessel and where the amount is then measured. It is one of the oldest time measuring instruments invented in ancient Egypt. Next is hourglass, also called sand glass, sand timer, sand clock or egg timer. This is used to measure the passage of time, it comprises of two glass bulbs connected vertically by a narrow neck that allows a regulated trickle of material from the upper bulb to the lower one. Factors affecting time interval were sand quality, sand coarseness, bulb size, and neck width. Analog clock. A clock or watch is called analog when it has moving hands and hours marked from 1 to 12 to show you the time. Some of the analog clocks have Roman numbers instead or no numbers at all. Similarly, we have digital clock. It displays the time digitally as opposed to an analog clock where the time is indicated by the position of rotating hands. It also gives facilities like temperature detection, date, month and year. Next is pocket watch. A watch that is made to be carried in a pocket. It has no wrist strap. Wristwatch. It has a wrist strap which enables us to wear it on our wrist. Next is stopwatch. It is a handheld timepiece designed to measure the amount of time that elapses between the activation and deactivation. It is of four types: analog, digital, manual and fully automatic. Let's talk about manual one. The clock is started and stopped by a person pressing a button. In fully automatic time, both starting and stopping are triggered automatically by sensors. The device is used when time periods must be measured precisely and with a minimum of application. Laboratories, experiment and sporting events like sprints are good examples. Next is smartwatch. It is a wearable computer in the form of wristwatch. Modern smartwatches provide a local touchscreen interface for daily use. Just like smartphones, it includes functions such as mobile apps, mobile operating system, Wi-Fi or Bluetooth connectivity, portable media player, FM radio and playback of digital audio, video files via Bluetooth headset. Also, it has mobile cellular functionality like making calls. Next is atomic clock. It is a clock device that uses an electron transition frequency in the microwave, optical or ultraviolet region of the electromagnetic spectrum of atom as a frequency standard for its timekeeping element. The development of atomic clock has led to many scientific and technological advances such as system of precise global and regional navigation satellite system and application in the internet which depend critically on frequency and time standard, also used in many scientific disciplines such as long baseline interferometry, radio astronomy. Similarly, we have radio clock. A radio clock or radio control clock is a clock that is automatically synchronized by a time code transmitted by a radio transmitter connected to a time standard such as radio clock. Thank you.